Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find links to subscribe, the entire back catalog, and links to all of our Twitters and blogs and all that sort of fun stuff. Once again, I have Jeff Squyres of Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey, Brock. Yeah, it's nice to be out in front of our recording schedule again. We've actually got a few queued up, and we're back on a regular schedule. This is good. We got kind of screwed up over the supercomputing and holiday season, and it's taken us a little while to recover, but now we're back, and this is a good feeling. What do we got for today?
So today we're going to be looking at one of the things people love to blame their problems on, networks. And so how do we actually test networks, and what are toolkits for supporting that? Yeah, you work for a network provider, and people love to blame the network. So we're going to be talking to Jason today from ESnet and one of the contributors to perfSONAR is what we're going to be talking about. So Jason, why don't you take a moment to introduce yourself?
Hi guys, so I am Jason Zurawski, and as Brock said, I'm a network engineer from ESnet, and ESnet is the Department of Energy's network provider. We connect up all the federal labs, and starting over the last year, we've started peering directly with universities to support our science missions. And we're a mission network, which means that we care deeply about being able to deliver on the process of science for all of our different end users. And because of that, making sure networks work is actually one of our main jobs. So the things that we'll be talking about today, perfSONAR, it's something I've been involved in for about 10 years. It really helps us make sure that we're running networks properly and gives us the tools that we need to support the scientists.
So give us an idea of what perfSONAR is.
So simply stated, perfSONAR really is supposed to be measurement middleware, and I'll try to unpack that a little bit. We already have lots of tools that can tell us how a network works. We have things like ping, or we have things like iPerf that can give us a network metric. And these are usually invoked by a user sort of on demand from their end system to some other remote location. We also have lots of passive monitoring tools as well, like SNMP, so that we can get counters from different network devices. But what we found is that there's not a way to share this information very, very cleanly. A test that somebody makes on their own, they keep that information in there. It's not widely shared with other users. So having measurement middleware, something that enables this sharing, has been a huge win in this space, because now we can invoke tests on different end sites. We can have a way to share them in the middle, and then we have a common platform that allows us to visualize an alarm. So when we have a problem that somebody has perceived on the network, we can identify it a lot quicker and hopefully get to a resolution a lot faster. And I think the last thing that perfSONAR really is this is a tool to raise user expectations. Many people aren't aware of how well they could be performing on a network with whatever task they're trying to do. And perfSONAR helps to level the playing field with regards to that.
So if you're the provider for all the DOE labs, it seems like you're one organization between all of it. So you mentioned the capabilities of sharing the results and things like that. Why is that important to you?
Well, so just sort of to noodle on that a little bit, and this goes a little bit more than just DOE labs. If we think about what a common science use case is within the DOE, it may originate from a lab where we have an instrument, something like a light source or a genomic sequence or something like that. There's going to be users that are sitting in universities or even commercial providers anywhere else in the entire world that are going to need to have access to that information. So they're going to need to use a network, and the network is just as much an important instrument of science anymore as the actual device that's creating this data. This network needs to be running cleanly and efficiently, and there's going to be many domains involved in the problem. To be able to really fully understand, we need to have visibility, and this visibility comes from a tool like perfSONAR. We can set up these regular end-to-end tests across domains, and we can then look at the results and then either determine if there is a problem. If things are looking okay, then there shouldn't be a problem for the end user, or get in there and debug things when we start to detect that there really is something that's going on.
So you're from ESnet, and ESnet's this network between DOE labs. There's also people like Internet 2 and Exceed uses Internet 2 and a bunch of local networks and uses perfSONAR and stuff. So there's a lot more people involved with perfSONAR. Can you give us a little bit of the history of it?
Sure. So the original idea of perfSONAR sort of came of a couple of different efforts, probably in the early part of the 2000s. There were really five different efforts that were sort of looking at a way to try to create, a standardization on network measurement. There was an effort in Europe called the GEONT2 JRA1 project, which was created by the EU government, but it had tenant members of all the different NRENs that were located in Europe. There's the Internet to End-to-End Performance Initiative, which was in the US R&E space. There was the Global Grid Forum, which was trying to just standardize measurement formats, not necessarily looking to develop software. There was ESnet, which was trying to roll out a new network at the time. And then there was also the RNP network in Brazil that had its own monitoring effort called MonIP. Each of these sort of met within that span of the early 2000s, and they decided that going alone was silly, so it's time to really combine into one effort. And the original software was released shortly thereafter, I think probably in about 2004, and it was originally written in Java. Since then, over the past 10 years, there's been many more implementations by these core partners as well as others who have received soft funding. And this has sort of created what we call today the perfSONAR toolkit, which is sort of the flagship product that we release. And this is a complete Linux distribution that also has all the perfSONAR tools, some glue in the middle to help with the administrative tasks. But it really gets to the core of what the mission should be, which is evaluating network performance and trying to evaluate it in such a way that people can understand it.
All right, so let's get into some of the details then. So you say there's a whole Linux distribution around your Common Core. What are some of these core tools? I mean, what kind of things are you testing?
So it's going to be some of the basic tools that many people are familiar with, something like traceroute or tracepath, the ability to look at a layer 3 hop count between two different end sites. We also have things like ping as well, a way to measure round trip latency. But there's a couple of other tools that people may not be as familiar with. One of them is called OWAMP. This is a one-way active measurement protocol. It's written in an RFC. And using a tool like this, we're able to measure each direction of a test independently, which is different than a traditional ping test. But we also get a lot more information out of it. We get packet loss, we get packet duplication, we get out of orderness, latency, jitter, which is the inter-arrival time between packets. A test like this is crucial to try to figure out if there actually is a problem on the network. It's run in an active manner. It's constantly run. And we're able to see macro behaviors on the network, things like microbursts and congestion that may appear in a very, very quick period of time, something that we may not be able to see with a traditional tool like SNMP monitoring, because that's designed to really pull on a slower interval, and that sort of masks over macro behaviors of what networks may be doing. There's other tools that are included in this, like BWCTL and iPerf3 that measure achievable bandwidth. All of these base tools sort of sit at the lower layer. They're the ones that actually perform the measurements. On top of it, we sort of have this sharing and this archival layer that stores the different pieces of data. And then we have the presentation layer on top that allows the user to configure the tests, but also allows them to visualize the results, configure them into an alarming system like Nagios if they choose to do so. So really, the entire Linux distribution is meant to sort of isolate the task of measurement, put it onto a specific machine that sits within the network somewhere, and simplifies your life so that you really don't need to worry about all these different things, which has been a huge win for operations staffs.
So you mentioned, dedicated machine, running these tests between the perfSONAR machines, trusting the links between them. But what if I actually want to get to my end desktop? What if I'm a researcher in my lab and I'm wondering why I can't get to my storage very fast or something like that, and I want to test a network? Does perfSONAR help with that?
Yeah, there's two ways that it could. So if we're talking about a desktop or a laptop, it's probably a system that has something like a web browser available. There's two tools that we've packaged on the toolkit for a long time. One of them is called NDT, which is the Network Diagnostic Toolkit, and the other is NPAD, which is a tool from Pittsburgh Supercomputer Center. Both of these are designed to be servers that run on the toolkit instance. So some provider would, of course, have to set this up and maintain it, somebody like Internet2 or ESnet, perhaps. The user can then visit this website via their browser and get a pretty good indication of what performance would be to their host. And what this